time for another Ask Your Meteorologist, and today I am joined by WCIA 3's Adam Sherwinski.
Woo!
So Adam, welcome back to ciLiving.
Yes, I feel like we do this a lot.
I know, at least once, sometimes twice a week, which is a lot of fun.
Yeah, which is fine. It's just, you know, during the morning shift, it kind of takes a lot out of you, right, sometimes?
Right.
So I'm kind of feeling it today a little bit, but that's
Are you? It's okay. I have enough energy for the both of us.
You know what? I think I just didn't have enough coffee, that's all.
That's the secret.
That's the secret,
And today we don't have an experiment. We're going to have a chat because I just have a regular question for you.
You do a regular question for me.
My question is, what is warm air, cold air advection, and how do you spot it on a map?
So cold air advection, warm air advection are kind of the same thing, but one has cold air, one has warm air. That's basically the difference. So we look at our graphic here. A nice handy-dandy graphic that somebody made yesterday. And, you know, you'll see we have that area of warm air. Down to the south, I don't know if you've ever been to Kentucky, Tennessee, Alabama, a little warm, a little humid, right? We have a warm front rising northward, right? That's where the kind of the leading edge of that warm air is going to be. Now, how does that warm air go from down south to up north? Yes, we have that warm front, but also, as that warm front rides northward, we're going to have wind, bringing in that air from the south to the north here. So when we have that activity, those southerly or southeasterly winds, that brings not only moisture, which we need for storms, but that warmer air starts to slide northward as we have that warm air kind of pulling it back in. So again, it's basically the wind transporting that warm air from an area that's got more of that warmth to an area that's colder. Vice versa, basically, for cold air. We have a cold front come through. Cold air advection really kind of happens right on the heels of that edge of that front. We have that cold air from our west. Usually here in central Illinois, we have our cold air coming from Canada and out west and move this way. And as it does, the northwest winds and westerly winds bring in more opportunities for cold air, and it kind of sinks back into central Illinois. So that's kind of how it works here when you look at it. Just the kind of basic idea. It's just basically that warmer air going to a colder spot, colder air going to a warmer spot, and the wind's kind of pushing it along and moving it along. So here in we look for northwest winds. We have cold air advection. We have a cold front come through, or northwesterly winds or westerly winds, and then southeasterly or southwesterly winds, depending on what kind of direction the warm air is coming from or where the source of that warm air is coming from. When we want that kind of have that where that source is coming in for our area.
So you could kind of say that the wind is that driver or the carrier. That is the thing that is sort of causing the cold front or the warm front to spread.
So the warm front itself is marching along, and it's just kind of the air moving in right behind it, basically.
Oh, I see. Okay.
Yeah, it's kind of moving through a fluid. Now we're going to take a look at a map here, and that map is going to show us, kind of give you an idea. Now here is something I don't expect you to be a master at this, but we're looking at a surface map here with temperatures. Okay. The darker colors, the purpley colors, the blue colors, those are kind of the colder colors. As you can see, you go down that way.
Oh,
there's a scale right there.
24 at the very, very bottom there on that scale.
And then it gets a little bit higher as you go on the right side. Warmer colors are going to be warmer. Now, you'll see that those areas that we have those pointers right there, those kind of arrows, those are winds falling along the pressure gradient, and that's pretty much going to bring in that warm air. So we have warm air advection happening. Where? From where, Jaclyn?
From here, pushing it this way.
Well, I would say basically Texas, Oklahoma. You could even say Mexico, moving it into parts of Missouri and Illinois. So that's a good way of looking at it. How about cold air advection? Where would you find that on a map?
Well, it looks like I would start with the blue because that's the colder part.
Yeah,
I feel like a meteorologist right now.
It's even colder in some other spots there, Jaclyn.
This dark blue.
Yeah, and see how it's kind of riding along, right, with those...
Through the purple?
Yeah, and so the areas where they're having the lines are really just our pressure. So there you can see we have an area of a little bit higher pressure rolling in. It's hard to tell. This map's a little bit old and goofy. And
what about the circular? What is that?
So those are areas that's an isotherm. So not isotherms, I'm sorry. Isobars. I had to get the two mixed up for a second. Isobars, and so that's the pressure. So the pressure changes, so higher area of pressure right there. If I can read the numbers correctly, it's hard to tell with some of these maps, but again, basically that's the gradient of pressure along with the colors being the gradient for temperature too. So when I look at this, even just by looking at it, I can say, okay, we got warm air there in Texas and Kansas, moving into the north and east with southwesterly winds, and then up north we've got cold air coming in behind a cold front. But that's the kind of thing we're looking for. We're not really worried about isobars and all that. I'm not going to talk about that for today, but I mean just the color gradient is really the key thing.
Is where it is
on these maps, right? So if I wish I had another picture and I could go forward in time, I don't have another picture, and you could probably see, okay, were you right? Yes, and you can see the cold air starts to sag to the south or move to the north and east. So
well, and to me it kind of looks like a thermal imaging map, when you see that kind of a thing. And my word,
if that helps you kind of remember it, then I think it's a good way of doing it.
Yeah, because I always think of thermoclines in the water if you're swimming and the water gets warmer. It's like the thermocline, and you can kind of sometimes see the heat waves and stuff like that. That's kind of what I see when I look at this map.
Water and air are both fluids, so that's one way of kind of looking at it. There's a lot of properties that water have and that air have that are very similar. So.
Very similar. Well, thank you so much for being here. I always learn so much in these Ask Your Meteorologist segments. I appreciate it. And if you want more information or you have a question for Adam, you can email him at asherwinski@wcia.com, or you can find us on social media.